Hello students, today we will study about the polynomials. This is the chapter number 2 of standard 9. So the first question arises in your mind is, what is a polynomial? Right? So in previous standard you have studied about the algebraic expressions. Right? So the polynomial is a particular type of algebraic expressions. So some of the algebraic expressions are here: 2x, 3y, 5z minus 2, 9xy, minus 4y square z. So these are some of the examples of algebraic expressions, and that algebraic expressions are called the polynomials. Right? But in this standard 9 chapter number 2, we have to study about some particular types of polynomials. What kind of particular polynomials? The algebraic expressions which has only one variable. Right? So here you can notice that there is only one variable x. Here also there is one variable y, one variable z, but here there are two variables x and y. Here also there are two variables y and z. Okay. So basically in this chapter we have to study about only that kind of algebraic expressions which has only one variable. Right? Okay. So now first of all, what is a variable and what is a constant, that you have to clear about it. The constant are the numbers which do not change anywhere, any place, anytime. The value remains the equal. While the variable are the quantities which are change according to the time, right? Like temperature changes from time to time. Similarly, there is one kind of quantity, that is a pressure, speed. All such quantities are called the variables because their values are not equal at every time. Right? They will change time to time. So this is the difference between the constant and the variable. So as I said that we have to study about some particular types of polynomial which has only one type of variable. So one of the example is this: x square plus 2x. This is an expression. Yes. Is there only one variable? Yes. Okay. So we can say that this is an polynomial, which is also an algebraic expression, but variable is only one. Okay. So here we called this x as an variable, this 2 as a constant, and whenever one variable and one constant come together in multiplication, then it will becomes an term. If there is also division like x upon 2, then also it will become an term. So how many terms are there? There are two terms. First term is x square, second term is 2x. So how terms are differentiated? Terms are differentiated by the plus sign or minus sign, either by addition or by subtraction. They were not differentiated by multiplication and division. Right? Here 2 and x are in multiplication, so we cannot say that there are two terms, because the terms are differentiated only by the addition and subtraction. So this 2x together is a term. X square itself is a terms. So there are two terms. Right? So the basic concept of constant, variable, term, polynomial is now clear in your mind. So we will repeat again. Whenever one constant and variable come together, then becomes a term. Such kind of terms are put, if we put together, then it will becomes an algebraic expression, and that algebraic expressions are called the polynomials. Right? Okay. So one of the example is polynomial in one variable is 3y square minus 5y plus 6. Here you can also notice that the variable here is only y. One variable is there. Right? So now you know what is what is the term? So how many terms are there? First, second and third. So there are three terms. First term is 3y square, second term is minus 5y, and third term is 6. You may wonder that why I have written here is y raised to power 1, because if there is no power on the variable, then we can consider it as a 1 power. Here also I have write down that y raised to power 0, because there is no variable here. We can write down it as in form of y raised to power 0, because any number or any variable raised to power 0 is equals to 1. So we can write down it as 6 into 6 multiplied by y raised to power 0. We are actually not changing the value of 6. We are just representing 6 into another form, in the form of variable. So you can notice that here we have write down this polynomial as decreasing power of the y. Here the power of y is 2, here the power of y is 1, and here is the power of y is 0. So this is basically the standard form in which we have to write down the, or we can write down the polynomials, right? Okay. So can you think about that? If there is only one constant, you have a digit constant here, then it will become a polynomial like that. 2 minus 5 7, are they polynomials? Yes, they are also the polynomials, and they are called the constant polynomials, because there is no variable. Into, it is a constant polynomial. Minus 5, there is no variable, constant polynomial. 7, again there is no variable, we can say it as a constant polynomial. Okay. So what about 0? 0 is called the zero polynomial, right? Okay. So now we are clear about that. What are the polynomials in one variable? Okay. So you can notice that in this polynomial the power of x is 2, x is 1. So it is a polynomial. Yes. Here also the power of variable y is 2, y is 1, and here 0. It is also a polynomial. Yes. So is there any algebraic expressions which are not considered as an polynomials? Yes. Some of the examples are x plus 1 upon x. We can write down it as x plus x raised to power minus 1, because we are taking this from the denominator to the numerator. So its power becomes minus 1. So yes, here this expression is not a polynomial. Why? We will see later. Second example is root x plus 3. We can write down under root x as x raised to power 1 by 2 plus 3 as it is. You can notice that the power of this x variable is 1 upon 2 here. It is also not an polynomial. Yes, they both are algebraic expressions, but they both are not the polynomials. Why? Because the exponent is not a whole number. This is the condition. If there is a polynomial, then there must be a condition that the exponent must be a whole number, right? Here the exponent is x raised to minus 1. Minus 1 is not a whole number. Again, x raised to 1 by 2 is an exponent. 1 by 2 is again not a whole number. That is why this kind of algebraic expressions are not considered as an polynomials. Okay? Okay. So now you know that what is the expression. Let's take an example and understand how to work as an expression, or how to express something. So let's consider one of the square, that is a PQRS, and its sides, let's take it as a variable x. So all sides must be x. Here we are not fixing the value of this side. That is why we have taken variable. Okay. So now perimeter of the square. What is the perimeter of the square? 4 multiplied by side. And here the side is x. That is why the perimeter is 4x. Okay. So as there is a variable x, we can express this thing as p in the bracket x is equals to 4x. Why p? Because p stands for the polynomial and x stands for that in our expression, what is the variable, is we have to write down here. So p of x is equals to 4x. If there is another kind of variable, suppose y is there in the expression, in the polynomial, we have to write down it as p of y. Okay, as there is variable x, we have write down it as p of x is equals to 4x. So what is 4x? 4x is the perimeter of square. We express the perimeter of square with 4x. Okay, so now what is the difference between expression and equation? That you have to consider, that you have to clear in your mind. So expression is this 4x. 4x is an expression, or you can say that polynomial is a kind of expression. And what is equation? If we fix this value 4x with some number, then it will become an equation, and there is an equal sign, right? What we have to do here, we fix this 4x value with some number, that is 12. So what we find here is, we find the value of x is equals to 3. So the value of x is fixed here, and what is it? 3, right? So this is an square of side 3. Each side on is 3 unit, and its perimeter is 12. This is fixed. So what is the expression? Expression is a polynomial. P of x is equals to 4x. Then what is the difference? See, if we change the value of x, we get the different value of p of x. If we take as x is equals to 2, what we will get? P of 2 is equals to 4 into 2, that is equals to 8. So if this square is of side 2 unit, then its perimeter is 8 unit. If this square is of 3 unit, then P of 3, we will get P of 3 is equals to 4 multiplied by 3 is equals to 12. Then its perimeter is now 12 unit. So as we change the value of x here, we will get the different value of 4x to the right hand side. And that is the difference between the expression and equation. Expression has many values. As we change the value of x, the expression value will be changed. And in equation, the value of variable is fixed. We cannot take any other value of x here, because 4x is equals to 12. We fix the value with some number, and that is why we get the value of variable, only one value of the variable. So this is the difference, basic difference between expression and equation. Okay. So now another term that we have to study here is the degree of a polynomial. Now what is the degree of a polynomial? Highest power of the variable is called the degree of a polynomial, right? So here you can notice that this is a polynomial. Yes. Variable is x. Yes. Highest power of this variable is here x. There is no power, so there is 1 as an power. So we can say that this polynomial has degree is equals to 1. So based on the degree of the variable, the polynomials are classified into 3 parts. One is linear polynomial, second one is quadratic polynomial, and third one is cubic polynomial. So the example of linear polynomials are 2x minus 1, under root 2y plus 1. You can notice that here x has power 1 and y here has power also 1. So the power, whenever the power is 1, maximum power of variable 1 is 1, that type of polynomials are called the linear polynomials. Don't be confused here that you may confuse that why root 2y is a polynomial. We have earlier studied that only the value of the variable, exponent of the variable, should not be another other number than whole number. We can take the coefficient of the variable as the real number. That means it may be a rational number or irrational number. But the power of the y must be a whole number. So this is the examples of linear polynomials. Now, quadratic polynomial. What are called the quadratic polynomial? If the degree of a polynomial is 2, then that kind of polynomials are called the quadratic polynomials. See the examples. 3 minus 3x square plus x minus 2. maximum power of variable x is 2. That is why the degree of this polynomial is also 2. Another example is t square plus 6. Maximum power of variable is 2. That is why these two are the examples of the quadratic polynomials. Third is the cubic polynomial. One of the example is 2x cubed minus x square plus 4x minus 1. So there are 4 terms and the maximum power of the variable is, here is 1, here is 2, here is 3. Maximum power of the variable is 3. That is why the degree of this polynomial is 3, and that is why this polynomial is called the cubic polynomial. One another example is y cubed minus 5y. Again here two terms are there. Maximum value of the variable, power of the variable is 3, and that is why it is called degree of the polynomial is 3, and it is under the category of cubic polynomial. So based on the degree, we can classify the polynomials in these 3 parts: linear polynomial, quadratic polynomial, and cubic polynomial. So is there any other way we can classify the polynomial? Yes. We can classify the polynomial based on the number of terms. Now you know that what are the terms, what is the terms. So based on the terms, again the polynomials are classified into 3 terms, 3 parts: monomial, binomial, and trinomial. Monomial, mono means 1. So if there is only one term in the polynomial, it is called a monomial, like 2x, 5t raised to 3, only 2, and minus 4y cube. These all are the examples of monomial. See one thing, notice one thing here is the value of variable, the power of the variable is 1. The degree of this polynomial is 1. The degree of this polynomial is 3. So it has not anything with the degree of the polynomial. We have to consider only the number of terms. Right? Second type is binomial. Binomial means 2. If there are 2 terms in the polynomial, we can call it a binomial. So 3x plus 2, there are 2 terms, it is a binomial. Y raised to power 30 plus 1, again there are 2 terms, it is a binomial. Third type is of trinomial. If there are 3 terms in the polynomial, we can say it as a trinomial, because tri means 3. So one of the example is u plus u square minus 2. Notice that 3 terms are there, it is an trinomial. One another example, under root 2 plus x minus x square. How many terms are there? 3. 1, 2 and 3. It is in the category of trinomial. So in this way, we can also classify the polynomials based on the number of terms into 3 parts: monomial, binomial and trinomial. Okay? So this is all about this introduction of this first chapter of the polynomial, second chapter, right? Okay. Thank you.